Hello everyone, welcome to Techie. We've all been there, right? You see that dreaded no internet message? It's so frustrating. But you know what? The fix is often way simpler than you might think.
I mean, when your internet goes down, it feels like the problem could be, well, anywhere. But here's a little secret that every IT pro lives by. You've got to start at the very beginning.
That's right. Before you start messing with IP addresses or diving into your software settings, you need to check the physical layer. Seriously, this is the rock-solid foundation of your entire network.
Okay, so what exactly is this physical layer we're talking about? Let's really dig in and break down the foundation of, well, pretty much all of our digital connections.
So it's layer 1 of a 7-layer model for computer networking called the OSI model. Its job sounds simple, but it is absolutely critical. It's all about moving the raw ones and zeros of your data. You can think of it like the plumbing of the internet. You know, the actual pipes and cables that carry all that information from point A to point B.
This layer is all about the stuff you can actually touch. It defines how those digital ones and zeros get turned into electrical pulses or little flashes of light. It's what determines the physical layout of your network, how fast your connection is, and even the super precise timing that keeps all of your devices perfectly in sync.
Okay, now this is where it gets really interesting. The way your devices are physically plugged in, what we call the physical topology, isn't always how they actually talk to each other. For example, you could have two computers plugged into the same exact switch, sitting right next to each other. But if they're on different logical networks, they can't communicate at all without a router. So the physical connections, that's layer 1. But the logical paths, that's all configured in software.
All right, so we get it. Layer 1 moves the bits. But how does an abstract idea, like a 1 or a 0, actually travel through a real physical cable, or just fly through the air?
Well, it all starts with what we call the transmission medium. This can be guided media, which is just a fancy way of saying a physical cable, like the Ethernet and fiber optic cables you plug into your devices. Or it can be unguided media. Those are the invisible electromagnetic waves of things like Wi-Fi that are zipping through the air all around us.
Let's say you want to send your voice over a network. We have to convert it from a smooth analog sound wave into digital bits. There's a process for this called pulse code modulation, or PCM. It's kind of like taking thousands of tiny snapshots of the sound wave every single second. Then it assigns a numerical value to each one of those snapshots. And finally, it converts those numbers into the ones and zeros that a computer can understand. It's a bit like creating a digital flipbook of the sound.
And guess what? All of this happens thanks to hardware you probably have sitting on your desk right this second. We're talking about the cables, the little plastic connectors on the ends, and the network interface card, or NIC for short. Yep, that's the port you plug the cable into on your computer.
Okay, so how does all this techie stuff actually help us solve our original problem? You know, that dead internet connection. Here is the single most important thing to remember. Since everything else is built on top of layer 1, even a tiny little physical problem, like a loose cable, can bring your entire connection crashing down. It's simple. Your software can't fix a broken wire. And the culprits? They're often surprisingly simple. It could be a poorly made connector, a cable that's been bent or stepped on one too many times, signal getting weaker over a long distance, or even interference from other electrical devices nearby.
Think of it like shouting across a really crowded room. The farther away you are, the fainter your voice gets, right? It's the same with signals. Whether they're in a copper wire, a fiber optic cable, or just traveling through the air, they all naturally get weaker as they travel. This phenomenon has a name. It's called attenuation.
We actually measure this signal loss in something called decibels, or dB. Now, this is a logarithmic scale, so the numbers can be a little deceiving. For instance, a loss of just 3 dB means you've already lost half your signal's power. And a 30 dB loss, that means the signal is 1,000 times weaker. A whopping 99.9% of it is just gone. That's a massive drop.
And it's not just about getting weaker. Signals can also get corrupted by interference. This could be electromagnetic interference, or EMI, from things like power cords or even those buzzing fluorescent lights. Or it could be something called crosstalk. That's when the signal from one network cable actually leaks and messes with the signal on another cable right next to it. That's exactly why it's so important to use properly shielded cables.
So, after all that, why does understanding this stuff even matter?
Because, well, it's the unsung foundation of our entire digital world. Think about it.
The most advanced software, the fastest processors on the planet, the most brilliant apps, they are all completely useless without a solid, reliable physical connection to carry the data.
Okay, so let's boil this all down. What are the key takeaways? First, layer 1 is the physical hardware that connects our devices. Second, it's the magic layer that turns abstract digital bits into real, tangible physical signals. And finally, because physical layer problems are super common but often really simple to fix, you should always check your physical connections first.
We really hope this explainer has helped shed some light on the foundation of our connected world. If you found it helpful, please give it a like, subscribe to Techie, and hey, drop a comment below with your thoughts or any questions you have. So the next time you see that dreaded connection error pop up, you'll know exactly where to start. Troubleshooting isn't magic, it's a logical process, and that process always starts with the simple things you can see and touch. Thanks for watching.